Let me start it by giving you some pretty, I would call it nonsense, but pretty standard expressions, but things you probably already know, but I would like to repeat. Number one, slow websites suck, right? We agree on that? Slow websites suck. Web performance is an essential part of the user experience these days. If you're not fast, people aren't going to use your stuff. Web performance matters, otherwise you wouldn't be here. And Varnish is a technology that could solve that issue for you. That's what we're all here about. Enough with the cliches. Hi, my name is Thijs. Yes, that is a Dutch-alike name. I'm not Dutch. Based on my accent, when I spoke Dutch, you can hear that I'm Belgian. Just drove in here. Don't worry, I won't be bothering you too long. I'll be driving out tomorrow night. So. I'm on Twitter. If you're on there, don't hesitate to follow me. It's an easy way to get in touch with me. Professionally, I'm a technical evangelist at a Belgian web hosting company called Combel. We're one of the bigger hosting companies in Belgium, and we're expanding to the Netherlands. We have this thing called Sentia in the Netherlands, which is a big brand, and it's our Dutch brand, so we're expanding to the Netherlands. We have offices in the neighborhood, so trying to conquer the Benelux, so to speak. In my spare time, if I have any, I run PHP Benelux, which is the PHP user group for Belgium, Netherlands, and Luxembourg. I organize events, I organize conferences, so I'm very much a PHP guy who ended up in an infrastructure environment. So a lot of the coding examples are written in PHP. If you're not a fan of PHP, I apologize, but that's just the way it is. So yeah, Varnish is a little bit our superhero of technologies. Now the difficulty for me today is to measure what your level of skill with Varnish is. I've even done these workshops for people who have no clue what Varnish is. So I'm gonna try to adapt myself to the level you guys have and the things you expect of me. I have a pretty good idea where we're heading in this training, but I'm open to deviation. I'm willing to deviate if that is a requirement. A word of warning. My talk has been mismarketed just a bit. So it says WordPress, Drupal, Magento. Yes, I could head in that direction. My goal is to teach you Varnish. And then if you still have WordPress, Drupal, Magento questions, we could apply those. Now the teaser, like the thing is, if you want to run this on WordPress, Drupal, Magento, there are plugins for that. And I could show you which VCLs to use. But the thing is, like not these things, these VCL files, these caching policies, aren't necessarily 100% tuned for all WordPress, Drupal, Magento sites. So having a bit of Varnish knowledge will help you tune that. Are there any people who have these expectations? Who is here solely for Drupal, WordPress, or Magento? For Drupal, but for Drupal, yeah. There's a couple of good plugins, but it would help understanding what Varnish does, how it behaves, because if you just install a plugin, run a VCL file, you have no clue what it does. So that's a bit of the goal. Varnish is a cache. Did everyone know that? Like, who has never heard or worked with Varnish? That I want to know. Like, okay, good. I like it. I like the fact that there's complete newbies because that will make sure that we can go step by step by step. Now, don't worry, we'll start from the beginning, but we'll go fast, so pay attention. Varnish is a cache. Anything else it could be? Any idea what it does more than just caching? Any ideas? Boom. Okay, let's try it. Let's see if this karma works here, because I have a next slide. No cheating. So what else can it do? So it could load balance, it could cache. Yeah, well, it could be proxy. Yeah, that's all proxy kind of stuff, right? Proxy kind of stuff. It's also, if you want to, a web application firewall, so on and so on and so on. The people at Varnish, the lovely people at Varnish, who I have to thank for being here, just call it an HTTP accelerator. That's what it is to them, and that's what it does. Now, I want to dive a bit into the theory of caching because there's some backlash towards caching that I've experienced over the years. People see it as a trick or as a compensation, and it's not. Why do people cache? Because they run out of ways to optimize their application stack. Now, I'm primarily a developer in an application or in an infrastructure environment, so I see things from a coding perspective first. So for me, the application counts, and infrastructure is merely an instrument to facilitate the delivery of the application services, nothing more, nothing less. So if your stuff is slow, you try to speed it up by putting in development time to look at the hotspots, use tools to see where the CPU and the memory is used. But in the end, you will hit that roadblock. And you decide yourself where that load block is situated. And you decide yourself if you invest more time and more money in optimizing your code. But in the end, you'll make a decision and say, enough. This is the limit of optimization we could do, and now we need to figure out other solutions. And caching could be a way to bypass or overcome those obstacles. Another thing is, so we're looking at this from an application point of view. If you look at it at an infrastructure point of view, you don't want to spend any more money on adding servers. Right? If you don't cache, like if you run these typical PHP applications or Java applications or what have you, it'll take resources. It'll take RAM, CPU, disk access, and those might slow you down. And you could say, well, let's try adding another node, and another node, and another node. But these are recurring costs, so that will cost you. So in the end, your CFO, CIO, CTO, whoever will say, enough with the infrastructure costs, we need to find other ways to keep this viable, to keep this interesting. And that's where caching could come in. But the thing that is a game changer for me is when I look back at the past. So I graduated, I'm not that old, I graduated in 2004. And I remember in 2001 when I started college, my database teacher said, we all know about database normalization, I guess, right? Normalize up to the, which form? 1, 2, 3, third form. And my teacher said, do not store things that you can recompute. It isn't worth the storage. Now that was back in the day when storage was a bit more expensive than it is now, right? And I would say the exact opposite in this day and age. Don't recompute if you can store it, but especially don't recompute. Does this actually work on it? No, it does not work on an LCD screen. Don't recompute if the data has not changed. Why spend CPU cycles? Why spend memory? Why spend disk access on constantly recomputing stuff from the database? Because the majority of the applications we write are just putting data in the database or retrieving data from the database. Why do that over and over and over again for every single page view if the data has not changed? Why do things like that? So that's my mantra. Cache at all times. Even when you have websites that aren't that big, you can already prepare for caching. So if you blow up, and I hope you do, I really, really hope you do, you're already well prepared. Make sense? All right. Varnish is really fast for those who you don't believe. Try running benchmarks on it. Who's from the Netherlands? Majority. You know the website nu.nl? You all do, right? Well, it's the story I always tell because a friend of mine used to work at a consultancy company called iBuildings in the Netherlands, and they built nu.nl. And I remember a couple of years ago at Schiphol, a airliner by Turkish Airlines crashed. You remember that? Disaster. Well, it crashed, and people who were in the vicinity took their bikes, because that's what you do, right, in the Netherlands? You take your bike, and you went to the crash site, and all the typical news agencies weren't there on time, but the people were. And they started recording it with their phones and started sending it to nu.nl. Nu.nl started exploding in terms of views because everyone was looking in that direction. It was like when social media and Twitter really started to rise, everyone went to nu.nl. So that's a nightmare in terms of infrastructure, right? Millions of people going there at the same time. They solved that problem with 2 Varnish servers. 2. The thing is, and that's the secret of the entire story, is they tuned their application 100% for that Varnish. And in that way, everything was served from cache. And they managed to deal with it with 2 Varnish servers. Why 2? Not because the first failover, yes, failover. Nothing more, nothing less. So that's a nice story. Varnish is really fast. Try it yourself. It stores everything in memory, if you configure it that way. By default, it's configured so that there's no disk access. Everything you cache is stored in memory, and it uses a threading model, a really good threading model. Paul Henning, the inventor of Varnish, is running around. He'll be here today. He'll be doing a keynote tomorrow at the other venue, and he is very keen on that. He is a FreeBSD guru, and he knows all about computer systems. You should have a chat with him. You'll be amazed. And he optimized that for the threading model on Unix-like systems. So that's why Varnish is so fast, because it uses threading in a really good way. Now, if you try to do a sales pitch about Varnish, the thing you mention most is the VCL, the Varnish configuration language. VCL is the thing in Varnish, and that's what makes Varnish so good, I guess, and so flexible, because you can tune your application in such a way. And it is if you configure it, you configured it in a reverse proxy model. And there is Ruben with the power cables.
Hello.
Hello. For those of you who don't know, Ruben is the community manager at Varnish Software. For the people who don't know Varnish Software, it is the company behind the Varnish Cache project. They offer solutions and services, but primarily they also fund the open source project, which makes it so nice.
That would be us.
That would be them. All right.
Connect to everyone on the Git here.
Ruben, can I bother you for 2 AAA batteries?
Yes, I'll be
Great.
right at work with them.
Yeah, no rush.
Like literally right away.
Yeah. Whoa, impressive, because it's giving me the sign that I need to switch. AAA.
Oh, AAA.
AAA. All right, let's continue. So the way we set Varnish up is like a reverse proxy with the emphasis on reverse. This is your normal setup. User wants to go to a website, connects to the server. Bam, nothing special about that. Now, if we think about proxies from the current days and the old days, this is the situation we have. You put a proxy in your office. Why? To hide things, right? Hide origin IPs, like control the traffic that's coming through. But in the old days, we used that to reduce the consumption of bandwidth, because broadband wasn't a thing. So you needed to cache what came out of the web locally so that you could put it over your LAN instead of using the very, very slow WAN connection. Things have obviously changed. Now the proxy is at the data center end, because this is so fast that this could be the bottleneck. So you put a system in front of it. And that's why we call it a reverse proxy, because it's reverse. It's at the data center. It's not at the office level. Okay, enough with the intro. Let's do things. We won't need our laptop immediately, because I've prepared that piece of the puzzle for you. But we are going to talk about installation and configuration in the beginning. You need to set it up. You need to get it working. Let's check who here runs, like who's a bit of a sysadmin in here. Who runs his own server? Okay, awesome. Linux? Yes. Who's a Windows sysadmin? Would like to know that? No one. Okay. We're safe.
Yeah. Let's keep the door shut. No.
Hey, I'm a big fan of Microsoft because they're good people. The people I get in touch with, and I have no problems with them. And they're a big sponsor of the PHP project. They pay a lot of money. So. And all the people I deal with at Microsoft are super nice to me. So I have nothing against Microsoft. I'm a Debian guy, kind of guy. Who's a Debian? Who likes Debian? Debian. Ubuntu. Let's see. Ubuntu. CentOS. Red Hat. A bit. Okay. Well, I primarily focus on Debian. And if you want Debian, I don't advise you to use the channels of Debian to install Varnish. Use the bleeding edge stuff. Register your HTTPS transport for the APT, and register the cache, the key for that. Now don't worry, these slides will be online. You will get them. I will upload them directly after the talk and give you the link, and you'll get a PDF. Thank you. So what you do here is just get your APT key so that the signing goes right, but this is the trick. Add the Debian channel by Varnish itself. Register it for Debian Jesse. That's what I advise you. We're all Jesse users. Still some Squeeze, Wheezy,
In between.
Lenny,
No.
Sarge, you know, old stuff. Then you apt get update, and then you just install Varnish, and you end up with 4.1. And I strongly advise you to install 4.1. A lot of, like, the surprising bit is I work at a hosting company, and I get in touch with all kinds of infrastructure, and a lot of people still use Varnish 3. Now, Varnish 3 is old. It's like end of life old. But the likes of Drupal, because I'm seeing this nice Acquia shirt, still has its plugins built on version 3. And that's not the fault of Acquia, it's a community thing, right? You have community plugins out there, and a lot of them are a bit outdated. So 4.1 is definitely the thing you need. If you're an Ubuntu person, see what changed? Not that much, right? Ubuntu, put it trusty, and that's it. If you're a Red Hat Enterprise or CentOS 7 person, this is the installation procedure. The only difference here is 6 and 7. Nothing special there. And then we need to talk about the config file. And the thing that confused me when using recent versions of Debian is systemd. Like systemd, for those of you who are unaware, is like the service manager It's caused lots of drama and death threats and things like that within the Debian community. And if you can either use systemd or sysv. So those are like the two things to do. If you run Ubuntu Trusty, by default you'll have the old way of doing things. If you run Debian Jessie, you'll have the new way of doing things. And depending on what you use in Red Hat Enterprise or CentOS, you might end up with sysv and systemd. The trick about this slide is to show you where the config file is loaded. And the configuration file contains the startup options. By default on Ubuntu and Debian systems, on older Debian systems, it's etc default varnish. That's where you'll find it. On the newer systems, if you use systemd, it's etc systemd. What happened there? Did it go into sort of hibernation mode? That sucked. Help? Like, seriously, help? They told me the TV would go on automatically as soon as I connect this. So I think we have to do this every 15 minutes now, I guess, because I was...
Don't you have the remote?
There is no remote. It's like all in here. HDMI. Yes! So it's etc systemd system varnish.service, and otherwise it's etc yada yada yada, right? You could, like, when these slides are online and you need it, just go to it. If you use Debian 8, that file I showed you is not there by default. You need to copy it. You need to copy it from libsystemd, so on and so on, to that location. If you don't, you're in trouble. And then you have all kinds of startup options that you can tune, and those are very useful depending on your situation. This is the Debian Jessie with systemd, and I marked it in yellow, what actually makes sense. You start out with the -a option, -a for address. It's the address binding. So in this case, it's bound to all available IP addresses on port 80. Port 80 being which protocol? HTTP, just quizzing here, right? Just quizzing. If you do a vanilla install of Varnish, that will be 6081. Why? Because it doesn't want to conflict with existing software. If you want it to run on port 80, do it. So in my experience, Varnish is not always the point of entry. You'll have TLS proxies in front of it to terminate your TLS. You'll maybe have load balancers in front of it, like HA proxy or anything else. In that case, you shouldn't necessarily change it to 80 because the proxies in front of it will have 80. But if Varnish is your point of entry, change it. Then the -T, bound to localhost on 6082, is your admin interface. There's a small admin interface that you can connect to over Telnet. That's how you do it. You have to connect only on the local host in this case. If you want to expose this to the outside world, you can like let go of the local host or just match the IP. I wouldn't do that. There is a level of security there with a challenge and a secret key, but if you don't need to, keep it internally. Speaking of secret key, -S is the location of that uniquely generated hash that you will need to authenticate. And -F is where the VCL is at. -F is the file, etc varnish default.vcl. That's where your main VCL file is located. And then you have -s, and that's the storage device. We're using malloc, which stands for, it's just your memory. And we had 1/4 gigabyte of RAM assigned to it, again, by default. Nothing more to it. If you want to reload it, use a systemd. Let's say we want to edit it to port 80, you vim it, or whatever, you Emacs it, you nano, you pico it, you whatever. But don't forget, whatever you change in that file, it's cached in memory. So you need a systemctl daemon reload, otherwise systemd won't do anything, you will just stick with the old. And then you reload Varnish and you're good to go. If you're on Ubuntu, it just looks like this. And it suffices to just vim it, reload it, and you're done. So no, that step in between, that systemd reload, that's not really required. So let's dig a bit deeper in all the options. I talked about -a, address binding, port binding, -t, -f, -s. This is what we have already. We explicitly have a VCL file in most of the examples, but it's not an obligation. You can omit -f, but then you will need you will need minus something else. We'll go through that. You'll need minus B to define your backend, because in the VCL file, your backend connection is located. I need to talk about minus J, right? Minus J is the jailing that they've done in Varnish 4, which gives you the opportunity to bind your Varnish instance to a user, a Linux user. So if you want it to be linked to www data or a separate Varnish user, you could do that. You can define the size of the memory locks. You can define the default TTL if you don't set a TTL for cached objects. You can set some runtime parameters, and so on and so forth. This is a way of doing things. This is an override where I use a Unix user, www data, to bind myself to. I added a second. This is an interesting one, and this is ever since 4.1, you have the opportunity to have Proxy in there. Now, Proxy is a protocol that is an extension of TCP, where you add a preamble, a small piece of the TCP package. You mention the original IP address of the front node. So if you have a proxy in front of it that supports it, you can have the origin IP and you can transport that all the way, because that's always difficult. If you have a proxy or another proxy, what is the original IP? What value do you set to the x404 header? How do you do that? Well, Varnish takes care of that. Since Varnish 4, x404 is set automatically. You don't have to care about that. But if you use a proxy bind and you have, let's say, HA proxy in front of it that does load balancing, terminates your TLS, it will send, if you use the proxy protocol in there, it will send that IP address all the way. So you don't need to care about that. So I advise you to have two binding ports, one on 80, one on 81. And if you don't have one on 81, we'll just use the default one. If you have something in front of it, then connect to it over the proxy protocol. And then we have some other stuff like memory sizes. I set it to 60 seconds. And we fiddled here with some default settings, minus P. So what I did here, we'll see about the ESI disable XML check. This is just a syntax change that I'm introducing just by setting these parameters. These are connection parameters I'm setting. So if we connect to a backend, it will take up to 20 seconds until it gives up on the connection. Once the connection is established, it will wait 100 seconds for the first byte. Once the first byte has been received, it will wait 5 seconds for the next byte. And we can tune those parameters to define what a healthy backend or an unhealthy backend is. And instead of those 256 megabytes, let's give that baby 3 gigabytes of RAM. It is advised if you're on dedicated Varnish servers to have about 80% of your memory allocated to Varnish. We were mentioning the backend before. Let's dig a bit deeper into the backend. The backend runs, like if you have an Apache or an Nginx server, it usually runs on port. Yes. And then we mentioned this already. Your Varnish, if you install it, it runs on 6081. Depending on the situation, you might change that. But if you run Varnish on the same server as your Nginx or your Apache, you need to change that port. If your infrastructure setup is big enough, you'll have dedicated Varnish servers. No need to reconfigure your Apache, because those will be separate boxes, depending on your situation and your budget. If you do have to change it, if you do run them on the same machine, which is often done, even on bigger setups, set your Apache imports.conf to 8080, change your vhost where the binding is not 80 but 8080. In Nginx, just change the listening in your vhosts. And that's about it. Linking your backend happens in two ways, either in your VCL file or by adding that minus B parameter I hinted a couple of minutes ago. You can omit the minus F, as I mentioned there, just do minus B, and you have a direct connection to your backend. If you use a VCL file, and I think in 99.99999%, we'll probably use a VCL, I guess. And this is the minimum amount of VCL you need to get going. Which is weird. In Varnish 4, you have to mention 4.0. I don't know why, because if you use Varnish 3 code, it won't compile on a Varnish 4. So, but then again, 4.0, semicolon, even if you use 4.1, it's 4.0, and it's not that much question. Let's just do it. And here you specify the backend. You call it default. If you call it default, Varnish will know that and will connect to it. Now, Varnish is all about HTTP. It follows the rules. Now, I've done this presentation 3 years ago here in Amsterdam at another event. And I named it There Are Rules, and I explained the rules. But instead of the rules, I'm going to talk about the way it respects HTTP. Like, it's not about you can do this and you can't do that. No, It has this mindset, this idea of how it uses HTTP. I'm going to explain that in 4 steps. It respects HTTP from an idempotence point of view. I will show that what it is. A state point of view, a time to live point of view, and a cache variations point of view. Idempotence sounds like a difficult word, but it's not that difficult. It's when you execute something multiple times, you want the result to be the same each and every time for the duration of the caching. That's idempotence. That's why get and head are cached by Varnish. But that's also why post, put, delete, patch are not cached, because those imply a change. Why cache a post when you know a post is going to change the state of that resource? So don't do that. Speaking of state, that's always the hardest part. When I do these pre-sales calls with clients who are interested in using Varnish, it's always about state, constantly. It's about state, and state means keeping track of state. And when you keep track of state, that means if you go to that website and I go to the website, we get a different view. It's about user-specific data. And user-specific data is checked in 2 ways in Varnish. Could be an auth header, like the typical server-side pop-up. Well, that probably means that the data is going to be different for you than for me, and it's going to be for your eyes only, not for mine. So that's user-specific data. On the other hand, we use a lot of cookies. And I hate cookies. I really hate cookies. I don't like cookies, but we need them. That's the mechanism we have in HTTP these days. Cookies come in 2 shapes and forms. A lot of people talk about cookies as being one thing, but cookies, from an HTTP perspective, is 2 separate things. You have the cookie itself, which is this value that is stored on your computer, and that has a set of keys and values stored in your browser. And as soon as a cookie is set for a specific domain, that cookie header, that request header, that's an import, is going to be sent constantly. All the time, that header is going to be sent. It describes the state, and Varnish won't cache by default cookies. When it sees a cookie, it says, can't help you. Here's a problem that we're going to tackle. Who uses Google Analytics on its website? It uses cookies. So that means, in theory, not in practice, otherwise we wouldn't be here, right? That if you use Google Analytics, you can't use Varnish because it uses cookies. Who has a login page on their website? It uses sessions, right? Sessions use cookies most of the time. That means if you have a login page, you can't have... Does Drupal have a login page? It does, right? So officially you can't use Varnish. We're going to try to solve that, but if you don't tune Varnish accordingly, all of this won't happen. Now, imagine those third-party tracking cookies. On the other end of the spectrum, you have the set cookie header. That's a response header. It comes from your backend. Your backend says, hey, you're requesting this resource. I'm going to set a cookie because I'm going to keep track of state. Varnish is not going to cache that either. As soon as it sees a set cookie, it doesn't cache. And I would advise you to keep it that way. Like in all the VCL setups we're going to do later on in the examples, when we see a set cookie, it really implies a state change. It's not us describing the state we have. No, it's the server resetting the state on your computer. So we really won't cache. If Varnish sees a set cookie coming from the backend, that happens on a miss, because otherwise you don't connect with the backend, it will blacklist it for 120 seconds. So it will cache the fact that it doesn't want to cache it. So that means when you're in your flow, and I will describe the flow in very great detail in a couple of minutes, it will say, instead of figuring out what we're going to do with it, we know already because we cached the fact that we don't want to cache directly to the backend for 120 seconds. That was state. The next bit is the time to live. Time to live, if you don't set anything, if you don't set any headers, it's 120 seconds by default. And if you, that's what I advise you is setting cache control headers yourself. Don't rely on general settings, control it yourself. I did a presentation a couple of months ago at a Varnish Summit, so that's their corporate events they're doing, this is community. And the talk was called, let the application do the work, not the infrastructure, not the config, not the VCL. As a web developer, because that's what the majority of you are, I guess, because that's how it was marketed, I want to give you the control on how to do this. Like setting cookies, if you set a cookie from your application, we're giving you control the state to change the state. If you run cache control headers, if you use cache control headers, we're giving you the opportunity to decide how long things will be cached or whether or not things will be cached. Expires headers work as well. So the difference between cache control and expires is that cache control describes how long it should be cached, whereas expires just describes the full date and time in GMT time zone when things should expire. And you can really overwrite that in your VCL file if you want to. So this is the order. If I would set the TTL in my VCL file, it will always respect that. It will have the priority every single time. If you don't, and if you control it from your application, it will first use asMaxH as part of the cache control header. asMaxH stands for shared maxH. It's a header that was, or a syntax of the cache control header that was invented for caches. Whereas maxH, and they're really bad at naming things. Look at this, and then here, it's not really consistent. The maxH was invented for browsers. But if Varnish doesn't see it as maxH, it will revert to maxH and will cache it. Let's say you cache it for 3,600 seconds. Well, Varnish will read that and will say, okay, next hour, that object will be in cache. If none of those are present, it will look at the expires header. And if none of those are found, we're going to the system default of 120 seconds. You can also use the TTL to decide not to cache. A lot of people are heavy on VCL to describe this URL should be cached and this URL should not be cached and this pattern should be cached and this not. If you could do it in your headers, it's even a better idea. If you don't want things to be cached, if you don't want a page to be cached, just set the maxH to 0 or the asMaxH to 0 or set cache control to either private, no cache, nor store, or use a really old date to specify that it should not be cached. And you can combine those values if you want to, if you do want to specify a cache. How long is Varnish going to cache this one?
1,000 seconds. Because it will fall back to the
3,600 seconds.
Yes. Why? Because asMaxH has the priority in this one. Your browser will cache it for 1,000 seconds. Your Varnish will cache it for an hour. To make matters more difficult, there's this thing called the age header. And the age header, I would advise you not to use it in your application unless you want to screw around with Varnish. But Varnish sets this for you. If you run through Varnish and you use your Google Chrome tools or your Firebug, you will see that header and it will define or it will say how many seconds it has been in cache for. The actual duration, the real cache duration, is the maxH or the asMaxH minus the h. So if you decide to set an age header yourself, it will be deducted from the time to live. So don't set the age header yourself unless you really, really, really need it. So we already had idempotency, we had state, we had time to live, and now we're going to go to the fourth part, and those are cache variations. The cache should not be the same for everyone, regardless of the identifier. These are the basic cache variations that Varnish respects. It will vary the cache based on the URL and the host name. That makes sense, right? If we go to the URL, we get the caching resource for that URL, not something global. So if your URL is different, it will change it. If the host name is different, it will change it. If you did not mention a host name, but you use the IP address, it will use the IP address. If you explicitly, in your code, want to have a cache variation, you set a header, response header in your code called vary. And you can do things like that. This is a common one, the middle one. Let's say you have a web application you've written, and it's a multilingual site. And you don't expose the language in your URL. You're basing yourself either on a cookie. Let's not consider the cookie right now, but let's say you use the HTTP mechanisms that are in place. Use the accept language. What I would do in your case is set a accept language variation header in your responses. And Varnish will respect that. So based on my request, I have a Dutch-based install. So we'll see, say NL_BE. Okay, we'll make a cache variation for that. And we'll store it in a separate object. But the main identifier, as I explained you, are the URL and the host name. If we would not set this vary header, and I go first, it will probably cache a Dutch version. Next person is a French person, we'll see Dutch content. French people don't like Dutch. There is a French person in the room.
The other way around though.
Yeah, I have no problems with French whatsoever. I live in a bilingual country and I don't mind speaking a bit of French, to be honest. So you understand the pitfall here, right? If you don't expose it in your URL, there is no default variation, so you need to vary that explicitly. Let's say you fiddle around with gzip encoding on your output. You're probably going to have to vary that. Let's say you have a browser that does not understand gzip or deflate. You're going to need a different encoding, or you need to vary on the encoding, because otherwise that browser, but then again, who uses browsers that does not understand gzip? IE1 or so, Internet Explorer 1 or what have you, we'll see a binary stream and we'll not be able to interpret that. But just to give you the idea that you can vary on whatever request header, that's the important one. You can't start inventing your own stuff. It has to be a valid request header. So you can, in theory, say we're going to have an X my header that you invent yourself, that you vary on, but then that header should be passed at the request time. So if you work with APIs where you can control the client end, you can set custom headers that you invent, like X dash whatever. But if you're dealing with people, like actual clients, you don't want to be messing with headers they don't have. And watch out with the vary cookie header. You can do vary on the cookie, but make sure you can control it within Varnish, that cookies are stripped off based on the thing you have. Like if you use a language cookie, you can vary on cookie, but make sure you trim that off to the outside world, because cookies could vary a lot. If you use Google Analytics cookie and you don't trim it off, it will be all kinds of values. So you effectively render your cache useless, because cookie values can be so much different. I've done a fair share of Varnish trainings, and the thing that screws with people's minds the most is the flow. I have to be fair and square. If you don't understand the flow, you will not get the rest of the tutorial. Anyone familiar with the flow of Varnish? How things run through? Cool. I hope I'm not repeating, because in the end, if it's too basic, I'm not sure if you'll get anything out of it. But then again, we'll leave that to the end. All right, you give me the feedback. The flow is a little bit like this. This is the finite state machine that Varnish has. This is just an image. It consists of 2 images. The screen didn't fit. 2 images. And you come up with a request. And these are the stages, the states where you come in. And they have seemingly funny names, but they're not so funny after all. You see VCL, and you see then a keyword. Every single request is going to be rec-v'd. It's going to be received. You're going to receive a request, and then you're going to make decisions based on state, based on idempotence, based on whatever. And then you're going to decide to either look it up in cache or do other things. Now I realized that I copied this directly from the Varnish website, that there's an error in this. Yes, it should go, like you could decide early on if things are not cacheable by default. So what is not cacheable? If it sees a post, put, patch, delete, or any non-RFC compliant request method, if it sees authentication headers, all that kind of stuff that aren't cacheable by default, it will immediately pass. It will say, this line should be drawn from here. It will be immediately pass and say, I don't want to deal with this. I do not want to cache this. And then you end up in the pass logic, and the pass logic, as you can see, it goes all the way down. From here, we're connecting to the backend in a separate worker thread. We're doing a backend fetch. We're reading the backend headers. We're setting the response or an error. We decide to cache or not to cache, and then we deliver it. This is a step that is executed every time, the deliver part and the receiving part. If you do decide to cache, you're going to do a lookup action. And that one is going to hash it. And you're going to end up in the next state, the hashing state, where you're going to decide about the hash key. I told you about the variations. The default hash key is composed of the URL and the host name. If you have no host name set, it will use the IP address. And next up, if you hash it, it'll either be a hit, a miss, or you're going to do other logic. One of the lines that was wrongly drawn by the people too is the purge. You can decide to purge things from cache. That's a separate chapter in this presentation where we talk about invalidating the cache. That's also important because it's always a balancing act between having a really good hit rate and still serving data that is not too stale. You need to figure that one out. So we could hit, we could miss. If it's a miss, you'll fetch it, and so on and so on. So that's basically the logic. You receive something, you decide if it's cacheable or not. If it's not cacheable, connect to the backend. If it is cacheable, it could be a hit. If it's a hit, you go to the delivery stage, follow the green line all the way to delivery. No need to connect to the backend. That's what Varnish is for, avoid backend connections. If it's a miss, fetch the backend using VCL backend fetch. If you fetched it, you'll get the response, and you decide to hit, not to hit, and deliver. Now, all these names aren't that funny. These are hooks. You're a Drupal guy, you know all about hooks probably, right? VCL receive hook, VCL hash hook, VCL miss, hit, pass, purge, pipe. These are all little subroutines in the VCL that we can override, and we can influence the behavior. And we'll need to influence the behavior, otherwise we won't be able to cache any cookies. And that will be problematic. So the VCL, the Varnish configuration language, is a set of hooks. So it's not a programming language where you can do anything you want. There's hooks in the finite state machine you hook into and you change the behavior. These are a bunch of hooks, like literally, you can see hooks on screen, where we can influence them, and we're going to go over every little one of them. Receiving, I explained this, makes sense. Request comes in, hash, compose a cache key, miss when it's not found. Whereas the pass is if you don't want to store it in cache. There's a difference between a miss and a pass. A hit is crystal clear too. It comes from cache. Backend fetch and backend response and backend error are the three backend states. You will fetch it from the backend. When it works, you'll have a response. When it doesn't work, you'll have an error. And then you can decide if you want to purge things from cache. Or VCL synt, when you want to create synthetic output. That means you want to return a response that wasn't necessarily cached and that wasn't necessarily fetched from the backend. You can do like hello world style output without connecting with any backend. You just compose your custom HTML or any other HTTP based output. Then you have the delivery part where you deliver data, where you can influence what headers are stripped off, what headers are added, and the init and fini, and that's for this afternoon if you're in still for the vmod workshop. That's where you could set up custom vmods. A vmod stands for Varnish module, and it's C code. It's like modules written in C to enhance and enrich the VCL language with custom features. Like you can write stuff in C and extend certain things. Extend logic, extend the VCL language. There are actions bound to these. So I showed you, let's go back to the state machine. These are the state changes. And you can see the actions linked to it. All kinds of actions. Now we need to talk about actions. In the receiving bit, so the title of every slide is the state we're in. And in red, I marked the actions you can do. If you're in the receiving end, you can choose to hash. Now, who has experience with Varnish 3? They completely overhauled the VCL syntax.
Yeah. Upgrading was no fun.
No. There's a script. Like Federico, who was out here, wrote a Python script that translates V3 to V4.
Including code
Flawless.
in it, with vmods and stuff like that. And we have done it now.
It took
would
some
have
time.
been great a month ago.
Yeah. Let's use our time machines, let's flashback, do a Git clone of that little project. Yes, there's a script out there. The reason why I'm saying this is what we call hash as an action used to be called lookup, and lookup is hash, which kind of makes sense, right? Because you're going to compose a hash key first before you look it up. They really optimized the way they name things. But if you're used to the old version, it will screw with your mind very intensively. You can also decide to pass, and that's another thing that happens. Like you see a cookie, and you decide not to cache. That's a pass. You can synt. You can do hello world style output. You could pipe. Pipe is something I need to explain. Like when you don't want to cache something, you pass. When you don't want to be dealing with caching at all, you just open a TCP connection to something else and you pipe. Like when you use WebSockets, you would probably pipe because you don't want to be dealing with any of the caching. It's just real-time connection all the way through. And then you don't use Varnish as a cache, but rather as a proxy. And you can purge. When you pipe, you can either pipe or still do synth. Like you could pretend that you do a pipe and then still output some HTTP-based output. You choose yourself. I know this is pretty standard, and you can use this as a reference afterwards. You shouldn't necessarily memorize any of this. But when you're in the passing stage, when you decide you don't want to cache anything, you'll either fetch from the backend, or you're going to restart your request, refire the entire process, or again, send. When you hit something from memory, in most of the cases you'll deliver. You still write VCL code to extend that behavior and still decide to miss and refetch it again and store, like synchronously refresh the data and store the new data if there's a criteria that hasn't been matched. Or you could say, hey, I decided not to cache it and not to cache it anymore, and it will then pass it and blacklist it in cache. You can restart, you can send, like you can do a lot of restart and send in most of the stages. When you miss, you obviously will fetch, and it's not stored in cache, you will connect to the backend, fetch the data, or still decide to pass, which is the same thing. It connects to the backend, but then it flags it as uncacheable for the next 120 seconds. And again, restart and send. Hash only has one stage. You look it up in cache, but you decide, first you compose the cache key, and then you look it up. Purging, same deal, nothing special. Delivery, same deal. You deliver it either, or you restart or synth. And even in synth, you could deliver or restart. Nothing special happening here. When you fetch something, so when you compose a backend request, so you get your original request in, and Varnish turns that into a backend request, you can fetch the data, or you can say, I had enough, and you abandon, and then it generates a 503 backend unavailable. When you receive a backend response, you can deliver it all the way back to the client. You can also abandon and say, hey, okay, maybe we could follow up on that presentation over there. You can abandon or you can retry. When an error occurs, you'll deliver the error. Mostly it will be a 503 or anything like that. Or you could retry. So those are the different stages, different actions. And the more we deal with solid VCL, the more I show you VCL code, and that will happen in a minute, the more you will know how these state changes work and what the actions are that we can use. Let's talk objects. So we have states that we can hook into. The different states of the state machine. Not to confuse it with the state of HTTP and the cookies. Those are different things. We have the actions that we can do, but we also have objects that we can use to change things. These are the objects, the primary objects we have. You have a request object that contains all the request information. URL, host, headers, and so on and so forth. For those of you who use ESI, and that's the magic trick we're going to see more near the end, or a bit further in the presentation, you can, like it's basically a framing, like you could compare it to a frame. And you can go outside of your frame and go to the top request when you're inside that kind of frame. It has nothing to do with HTML frames whatsoever. I'm going to hint towards it, but you'll see in some time that ESI is a really powerful mechanism. You have a BREC, BE, backend. So that's a copy of the request. It turns it into a backend request that only happens when things are not in cache. Otherwise, you don't have a backend request. A BRESP is the backend response. That's the response that comes back when you fetch it from the backend. And then you have RESP, which is the response that will be sent as output to the client. That's what comes in, that's what goes out. This is intermediary stuff. And this is what's going to be stored in cache. It's going to turn that BRESP and that RESP into an OBJ, an object, and it will store that in memory in most of the cases. And then you have these additional objects that you can use, such as client, server, local, remote, storage, like these utility methods. And then you have variables on these objects, and that's where it gets, I just added the 3 dots because these are just examples. If you want the URL of a request, it's rec.url. When you want the host, rec.http.host, and so on and so forth. You can get the user agent, accept language, every single header is in rec.http. You can hint towards the backend to use, and that will have some load balancing examples. That's where you select which backend you connect to. You can do that very dynamically. You can write your own code to decide if it goes to server 1, server 2, server 3. You can make that pick. You can get the method, like everything that comes from the client, you can choose. And in the BREC, you could do very similar stuff. You can connect, you can see what the backend will be. When you have a backend response, you can get all the headers you need. You can get the age, you can get the backend IP, the name, all the HTTP stuff, the status, if it's cacheable or uncacheable, grace mode, keep mode, we'll talk about grace and keep later on. So lots of information. And you have client variables like the IP, the identity, the local connection, the remote connection, all this somewhat useful information you can use. There's object information. How old is my object? Is it a grace? How many hits have been registered on that object? Is there a header, specific header being set? What is the reason? So the reason is the payload, the data, what kind of text, HTML style text is in there? What's the status code? What's the TTL? Then the REST variables. What is the user agent that I'm sending? No, that's not really correct. That's a typo of more because that's should be a request, right? Yeah. I wrote that slide yesterday, so it might be the reason. Was it streaming? What is the? Yeah, you see it, you name it. Like there's a lot of things you could do. You could request information about the storage engine. So to summarize this, you have hooks you can hook into. There are objects there. Objects have variables you can read or under some circumstances change because you can optimize URLs, you can make URLs look prettier. But there is default behavior, and now, based on all the things we learned, I'm going to show you what the default behavior of Varnish is. The next couple of slides will contain solely VCL code. VCL code that if you start up Varnish with the minimum amount of VCL, that would not necessarily have to be there. If you don't specify VCL, it will have backend, in the backend or in behind the scenes, Varnish will have its default behavior hard-coded. If we would translate that hard-coded C code into VCL, this is what it would look like. Ready? This is the real deal. This is VCL in action. We start off by setting VCL 4.0, and we register our receiving hook. That's something that happens every single time. You get a request in, and then you start deciding. When the method is PRI, we don't want to be doing anything. We don't even want to deal with that. We're going to 405 it by default. That's a method probably used to upgrade to WebSockets, if I'm not mistaken. No, it's SPDY. It's HTTP2. It doesn't want to deal with HTTP2 yet. Teaser, I think in September. Varnish 5 will come out with HTTP2 support. Supposedly. But I know it's an open source project, so the deadline is probably when it's done. But still, it's a much anticipated thing. And if you stick around tomorrow, which you probably all will, Paul is going to talk to you about it. I think Lasse is going to talk about the release, upcoming releases. So. Right now, it doesn't want to deal with HTTP2 or with the speedy dialect of HTTP2. When it sees non-compliant RF or non-RFC compliant methods, if it's not get, head, put, post, trace, options, and delete, and patch is supposed to be in there too, normally, it will say, hey, I don't know what this is or what you're trying to do, but it's not HTTP in my book. I will pipe my way out of this and going to connect to the backend, just set up a TCP connection, just forward all of it and take the response back. We won't take any decisions on caching, just pipe. Next up, this is the idempotence piece. If it's not a get or not a head, it means we are changing the state. And we're going to pass on that. Passing means we're going to send it to the backend, and when it comes back, we're going to mark it uncacheable for 120 seconds. And every next time we come here, we just directly fetch it from the backend. Here's where state kicks in. When we see an authorization header or a cookie, we're going to pass as well. Under all other circumstances, we've met the criteria of idempotence, of state. We're going to hash. We're going to look it up in cache. Next part, the hashing logic. By default, and everything I'm going to say is by default right now, is going to use the URL to compose a hash key, and if the host is set, it will use the host. If no host was set, we'll strictly use an IP address, and we're going to look it up in cache. This is modifiable. You could add whatever you want here. When you decide to purge, when you call the purge, it will say synth. This is our synthetic output. It will return a 200, HTTP 200, and it will just say purged. It won't connect to a backend. This is just output. When you hit, and the TTL still is bigger than 0, it's not stale, it will deliver it. If there was grace mode introduced, it will keep it longer in cache. Grace mode is a mechanism we use to keep things longer in cache for a given point in time, to make sure that we can, if the backend is failing or if something has expired and we need to connect to the backend, that you keep serving the old data while the new data is fetched asynchronously. If none of these criteria were met, we're dealing with outdated data, and it's a miss. It's a miss. We're going to synchronize the data, store the updated object in cache. If it was a miss, we'll fetch. So this is a state we're doing. We're going to miss. We're going to fetch, do a backend fetch. If we deliver, we just deliver. This is the synth piece. This is HTML that is set. A thing I like, and was kind of mind-boggling to me, is that they use guru meditation. Gurus meditating, apparently. Backend fetch will fetch it. This is where it gets more interesting. When we get the backend response back, so you know from the receiving end, we decide if things are in theory cacheable or not cacheable. So we make a decision there. When the data comes back from the backend, we decide if we want to store it in cache. If the TTL is equal or less than 0, that means the backend doesn't want us to cache it, then we won't cache. If there's a no cache, no store header, we will not cache. If there's a set cookie header, we will not cache. And we will not cache means we're going to set the TTL to 120 seconds and we're going to mark it uncacheable for the next 120 seconds. And then we're going to deliver it. If errors occur, output will be generated. And that's about it. This is default VCL all the way in action. Even if you don't store any of this in your VCL file, it will still behave the way it does. Right? Still on board? We're about an hour in. I suggest continuing for half an hour. Take a short break. Because attention spans, you know all about that, right? Sorry? Squirrel. So minimal VCL, we already talked about minimal VCL. Now we're going to go into custom. So this was default, now we're going to slightly customize. And that's, if I were to take a Varnish course, that would be the reason why I take it, to learn about customizing my VCL for the application at hand. This is the minimum. You already know that, because it's the third time I showed the slide. But you can, the reason why I put the slide in to show you, see, back and forth, you can extend the backend. You know these -p parameters that I set hard-coded in the startup options? Connect timeout, first byte timeout, between byte timeout. You can define that at a backend level. You can override that. If you know you have a backend that is kind of flaky, because in a lot of cases you'll be touching, so you see an old server and you say, we're not going to touch it. Because as soon as we even put the dust out of it, it will crash and burn. And you know it's flaky and you know it's slow. You might want to increase those. A useful one is max connections. If you know that your Apache can only handle 300 connections, you're not going to set max connections to 500. You're going to set it to 300. And then it's going to queue the request just to save your backend. Now the goal is that all the things will be cached. But the reality is that hit rates might vary a lot, and you don't want to be clogging that backend. Let's add more. We can even add probes to it. And that is a way to define, because you have a rec.backendHealthy, define if a backend is healthy or unhealthy. So you set a probe, I pick the root, and every 5 seconds is going to check that URL. And if it gets to 200, it'll be very happy. And then it will say it must respond within a second. If it doesn't respond in a second, it will be marked unhealthy. And you have a window and a threshold to decide how many times it has to be successful to be considered healthy and how many times it can fail before it's considered unhealthy. And you can go even further and you can define custom request headers. Like you could do a head if your backend is optimized for head, which I strongly advise you. Then you could set even more. So you can treat this as a load balancer if you want to. And you can use these probes to define which are my healthy backends, which are my unhealthy backends, and balance in between. So this is the next step. This is our typical backend that you saw with the extended probing, and we're going to import a vmod, a module that contains director logic. Now, a director is a load balancing strategy. So it's actually an object that behaves like a backend, but in reality has multiple backends connected to it and just starts selecting. So this is our primary backend, 1, 2, 3, 4, just for the sake of this example. And the next backend is, see, 1, 2, 3, 5. If we want to round robin load balance, in the VCL init hook, we're going to register that vmod or that director with the vmod logic in hand. We're going to add backend 1, server 1, and server 2. Server 2, server 1. You register them. And then you do the backend hinting. And that's what we did so far, right? rec.backend hint is vdir.backend. And then it will start round robin load balancing. Server 1, server 2, server 1, server 2. Back and forth, back and forth. We're doing load balancing. We can also randomize this. See where it changes? From round robin to random, and you add weights. If you know that one server is more powerful than the other one, you don't want equal balancing, you want the one to have more requests than the other. That's the way you do randomness. You can also do fallback, where it always connects to server 1 unless it's considered unhealthy, and then it will fall back to server 2. One I kind of like is the hashing director, where you can say that you will distribute based on the URL. And that is especially useful when you have multiple varnishes. Let's say you have a load balancer in front of it, or you have a varnish. That happens as well. Now your mind is going to be blown. You have a varnish that sits in front of other varnishes. And those sit in front of your web server. And the front one, let's say you have 4 gigabytes of RAM in your machine. And you allocate 3 gigabytes to varnish. And you have 10 gigabytes of objects you want to cache. And you want them to be in cache at all times. And you want it to be in memory, not on disk. So what you might do is set up, because 3 times 3 is 9 gigabytes, that's not enough, so you'll have 4 varnishes next to each other, and 1 or 2 varnishes in front that do the distribution. And in that way you can specify in advance which objects go to which cache, so you could stretch your cache. Because mostly if you do round robin or random between varnishes, you will have duplicate data all over the place. You'll have 3 gigs there, 3 gigs there, and you only have 3 gigs of data. If you use a hash director, you could send traffic to a varnish or a backend, an Nginx, Apache. Based on the URL, it will compose a hash key on it, send requests to that one. And that way you can stretch your varnish cache or stretch the request that you send to specific locations. And you shouldn't only rely on the URL. You can use the client identity that you can define. It could be an IP address, could be a user agent, could be whatever you want it to be. You can even do tune it yourself and do conditional load balancing. If my URL starts with products, with the regular expression match on products, it will use server 1. Under all other circumstances, use server 2. So you can really tune which way your requests are going, to what backend they're going. That's one piece of the puzzle. That's one way we could use VCL to tune our application. The next tuning that will happen is request normalization and response normalization. This is a bit of custom VCL that we use to normalize our input. We're using this STD, the standard, it's not STD as in English, right? STD as in standard. It's nothing to do with anything else that you can acquire in Amsterdam. We're going to use regsub, which means regular expression substring, and it will replace logic. Substitute, thank you. I was unsure of that. I was waiting for someone to correct me. It's not that I knew the answer, I was very unsure what the sub means. Sub as in substitute. And it will trim the port of the host. Let's say you use port 80, but it will be a cache variation because that's part of the host. And we don't want a cache variation on that because if you omit port 80, we want the same result to be returned from cache. We want to increase our hit rate, we're going to trim that one off. This is a very useful one, this one. std.querySort. If you have query string arguments, key equals value, like question mark, key equals value, and ID equals 5. If you put them in another order, it will give a miss even if the other order is stored in cache. So by doing a query sort, you will sort them and always have a hit if any of the combinations are in cache. If you have these anchor signs that are used to navigate through a page up and down, it's the same page. Don't use it as a cache variable. If you just put a question mark behind your request but no parameters, you're dealing with the same request. Trim it off. If you're using variations of the gzip or deflate that aren't official, you'll have variations as well. So you want that to be either gzip or deflate, or just remove it. If you use MSIE 6, of course. Not sure he uses that still. You can do that. So this is normalization from the user end, like from the request end. You can also deal with static assets. Some debate going on in the community how to do that. This is a way of doing this. I know, I'm seeing your facial expression. It needed to fit all on one screen. I know. If the URL contains one of these extensions in the end, these are extensions that are considered static, not dynamic. You're going to strip off the cookie and you're going to look it up. Because no one, practically, like in theory, no one really wants to know the state or wants to keep track of state in static data. Why would you want to know a cookie value in a JPEG? Maybe if you generate that JPEG on the fly, you might want to know. That might be an exception. But under all other circumstances, you don't care. And you just strip off the cookies. Bam, gone. When you receive one from the backend, you don't want set cookies to be there in any form, shape, or way. So you trim them off as well. Here's the next bit. If the stuff you receive from the backend are large binary files, you don't want a cookie either. You want to stream. You want to enable the streaming option. And you definitely don't want gzip compression. Because why compress something that is already binary? You'll be wasting CPU cycles on that. So you could set the do gzip to false. Cool thing about Varnish is even if your backend doesn't offer you gzipped data, Varnish will gzip it for you towards the client to reduce the data over the wire. And here's the big debate. Do you really, really, really want to cache static assets? I was talking about stretching your backend and having gigabytes of storage. A lot of people cache all their images, which is fast. It's really fast. But if you're doing a balancing act between conserving memory and having a high hit rate, I would advise you under most circumstances not to cache any static data. Why? Because it's usually not the bottleneck of your application. It's usually the database, external feeds that you connect to that are used to compose the output. Those will slow you down. Those you need to cache. But an image, here's the trick. Nginx or Apache would be just fine. Especially Nginx, it has a very low memory footprint. It's very stable even when, it's designed for the 2K, the 10 CK problem, right? 10,000 or 10 million concurrent connection. Look, it can handle a lot. Let's just call it that. It can handle a lot of concurrent connections, Nginx. And in a lot of cases, and I know when we use the word benchmark, people will cringe, I know. You can prove whatever you want with benchmarks, but still, Nginx in a lot of cases could be just as fast as Varnish, sometimes even a bit faster than Varnish, just for static data. So why pre-allocate memory and waste memory if any of those could just do it? And then you could say, hey, I am going to strip off the cookie, but I'm going to pass it or pipe it or whatever. We're not going to deal with it. We're not going to fill up our memory with things that don't change and things that can be handled pretty rapidly through Nginx or Apache. That's another end of the spectrum. The next thing people do in a lot of cases is do URL whitelisting and blacklisting. And that happens often. Any idea what CMS that is?
WordPress?
I thought it was...
No.
It looks like... It looks Drupal-ish, right? I stole a bit of VCL from Drupal. What this does is it states what URL patterns not to cache. Which is also useful in this case, because if you use /user or /admin in Drupal, you're hitting the backend, and in a lot of cases you don't want to cache your backend because it's highly dynamic and highly user-centric, very, very stateful, as we call it. So these are ways you can do it. You can use regular expressions to match certain patterns, and then you can decide to cache or not to cache. That's a pattern that you can use. If you can do that with cache control headers, that would be nice as well. If you could say max age 0 or no cache, no store, would even be better. But in a lot of cases, developers don't have the discipline to control all of this using headers, and we just revert to hard-coded black and white lists. This is a white list. Everything that starts with products, we do explicitly want to cache this. You see that in a lot of situations, and you will have that in your own applications too, under most circumstances. You will decide this part will cache, this part we don't cache, and you can, in a lot of cases, identify it based on the URL. Still with me? Still on board? Still ready for 5 more minutes until the break? All right. Those damn cookies again. I hate cookies. But I'm not going to complain. I'm going to offer you solutions to the cookie problem. This is a typical regular expression substitution to all occurrences. It will examine the cookie, and it will look for patterns like has.js, __, UTM, and what have you. It has a dot after it. The GA, Google Analytics, GAT, you name it. Whenever it sees a tracking cookie, it will remove the tracking cookie. I used to be afraid of that, because I thought that if I remove that cookie, won't I have any hits anymore in my Google Analytics? Will the data be skewed? Answer is no, because the web server doesn't really care about Google Analytics. It's a JavaScript thing. Google Analytics stores the state of Google Analytics. It stores your tracking cookie, your UA cookie on your disk or in your browser memory, and it will just use JavaScript to send it back and forth to Google. Your web server doesn't even know, and doesn't even need it. But it does pollute your traffic. So you strip everything off. So every time you see a cookie that has any of these values, you'll replace it with an empty string. And in the end, if your cookie is a collection of empty strings, or spaces, or tabs, remove it. Remove the cookie entirely. Or another pattern that I see in a lot of cases. Remove all cookies except, let's say, the PHP session ID. Because when that cookie is present, that means someone is logged in, and you don't want to be caching them. That's a pretty decent pattern. Remove everything except one specific cookie. To make matters even more crazy, imagine you have a website that has language selection, and the language selection is based on a splash page. You know, the typical one, right? Splash page, choose your regions, choose your language. And the moment you do that, it will store your region or your language in a cookie. But you'll need that cookie. That's kind of strange because I've been like bashing cookies all along. But in a lot of cases, you might need that cookie. So if a request comes in, remove all cookies except the language cookie. And here's where it gets interesting, do an extra cache variation on the value of the language here in your regular expression. When it's NL, make a cache variation on NL. That's for people who don't use accept language or don't expose language in the URL. You can use that cookie. That cookie will help you to have a good cache variation. That's the way of doing it. And you see that I'm not doing a return here. That's important to know. It's not only the cookie. It will use the cookie value, and then it will default because I'm not returning on default behavior. And if you remember default behavior, URL, hostname, or IP address. That is a useful example, and I've used this in production for clients who use splash pages for languages. There are, of course, alternative ways of doing it. You can explicitly say if you don't use vari headers, hash data accept language, that will do it. If you can, please use a vari header. Do it in your application. If you can't do it in your application, you could use hash data for that. Another thing I've seen is hash all cookies. That only works if you have a really solid and disciplined control over the cookies you use. Under all other circumstances, you'll make cache variation after cache variation after cache variation, and your hit rate will go spiral down to practically nil. All right. I'm going to hint towards the next chapter, which that includes. But that will happen after the break. Let's just continue and see what happens. Page, but we can store the main page if we want to. And Varnish will load that. Varnish will parse that. Varnish will compose that as output. And in the examples that we'll be reaching soon, within a half an hour, we'll be doing examples. You will be seeing ESI in action, and we'll have examples. We'll be able to play around with ESI. And then this is the tag we're loading, this little piece. And I like to use date and timestamps for caching. If the timestamp doesn't move or doesn't adjust, it's cached. It's an easy marker. So we're caching it for 10 seconds, and Varnish will respect that. The main page will not be cached, but that tag we're registering, that ESI tag, will be cached for 10 seconds. You can do it the other way around. Cache everything except that little piece that is uncacheable. Very, very useful. Very useful. Then a couple of weeks ago, when I was working on the example, I hit this error in the logs. No ESI processing because the first character is not an opening tag. It's not XML compliant. And it says C feature ESI disable XML check. So it expects all the output to be XML or just HTML or XHTML. So it needs to start with that little thing. We don't always want to do that. If you don't, just add that little feature. And we already had that early on in the example of the installation. Just put that little option there, and it will no longer validate what's coming out. If you want to do JSON, by all means, like you can cache APIs and have a little piece that is dynamic, and all the rest can be cached. That's something we could do with edge side includes. There are downsides to edge side includes, a lot of them. The cool thing is it's composed at the server level, so your client doesn't have to do mix and match, but it is not graceful degradable. So that means if your backend fails, one of those tags fails, your entire page falls over and you get an HTTP 503 error. That is not so good. Then it happens not really asynchronously, and it does it sequentially. So if you have 4 ESI tags, it has to do 4 sequential requests. If one of them is slow, it just piles up. It's not yet optimized. It could be done better. Maybe in Varnish 5, it'll be done better. If you have ideas, talk to Paul. He's here. What are your other options? If that is an issue to you, simple. Ajax could do the trick. But then you render it at a browser level, and you rely on the browser to do it. But the cool thing is that you could probably do it in parallel, not sure, not a JavaScript expert, and you can have graceful degradation. If, let's say you use jQuery to do that Ajax call and it fails, don't load the block. Instead of sacrificing your entire page for that little feature that doesn't work, why not just sacrifice that little feature? Let's say you have a calendar widget on your site and it fails, let it fail. At least the rest of your pages work. That's my advice. And you can pick ESI to ESI or not to ESI, and that's then your question. Like, not really mine. You have both. Then another piece of VCL that we'll be doing is hard coding the time to live. We can set this 1 to 3 hours, and everything will be cached if it's cached for 3 hours. You can use if structures or match on certain things to decide. Like if you see that you're working with this legacy application that you don't have any opportunity to insert cache control headers or to control the time to live, just do matches there. Like if it starts with /products, we're going to cache for 3 hours. If it's /admin, we don't want to be caching. And this is also a piece of the puzzle. This is default behavior in Varnish. If there's a set cookie or a vary header on everything, that's another thing. If you see a vary header on all the fields, if you vary on all the fields, you're not caching, right? Just storing separate data. If you want to make something uncacheable, there's also TTL, 120 seconds. You can change that behavior as well. My motto is don't use that unless you really, really, really need to do it. Just use cache control headers. Use the smaxh for Varnish, use the maxh for the browser. Next up, small example, small snippet of code, debugging. This is something I particularly like in a debugging context. Is at the delivering end, when you deliver the output, you check how many hits your object has, and if it's bigger than 0, set a custom X cache response header and make it hit or miss. That way you can easily use Firebug or your Chrome developer tools and see if this is actually coming from cache or if it's composed from a backend request. Very useful. And we continue. We want to anonymize things. At the delivering end, we can strip all the headers that expose what we're about. Maybe you don't want the people to know you're sitting behind a Varnish. Maybe you don't want people to know that you have a PHP-based X powered by PHP, because maybe a version is exposed by PHP, and if that's a flawed version that they haven't upgraded yet, you might be subject to hacking, to attacks, to brute forcing, whatever. Maybe you just want to strip all of that off. This is a hard part. This is, you remember that saying that there's only 2 hard things in IT? Who knows that joke?
Naming conventions and cache
Invalidation. And off by one error.
Off by one errors.
There you go, you get it. So invalidation is really hard. And as I told you earlier on, it's a balancing act between having a really high hit rate, but still being able to give people that breaking news. Because if you don't, from a functional perspective, commercial perspective, you don't exist. So you need to be able not to... There's one thing of estimating a good time to live. That would balance things out. Another thing is to actively invalidate it. And Varnish has means for that. There's a purging syntax. This is custom VCL, where I check if the method equals purge. I do this very early on in the flow. So you're seeing that I'm not returning anything here. I'm relying on the default behavior. But the reason I'm doing this early, because in default VCL, purge is not considered a compliant method. And it would do a pipe if we don't do that early on. It'll just say, hey, purge, I don't know what purge is. That's not official. It's not an actual HTTP header. Boom, done. Pipe, send it away. So we need to do that here. Another thing is, if people would know you're sitting behind that there's a Varnish in your setup and it has purge, I would purge the hell out of your website. I would write scripts that purge every single thing. I would crawl your sitemap.xml and constantly purge everything I can.
You're not a very nice guy, are you?
I am a nice guy, I'm just saying that. And then I'll send them an email saying, hey, you might want to fix this. That's why you put an ACL in your VCL. And it mentions host names, IP addresses, subnets, whatever you do to identify the purger, and you limit them. If your client IP is not in that list, well, hell, 405, method not allowed, not allowing you to purge. If you do, return purge. Return purge goes into the VCL purge bit, and it sends a 200 purge. Done. That's not all of it. There's more to it. That was purge. What purge actively does is remove it from memory. It's like, object gone. Next one has a miss, fetches it, problem solved.
What does ACL stand for?
What does?
ACL stand for?
Access list.
Access list.
So it's I think it stands for access
Control.
Access control list. Access control list. We can control the access by using a list. Yeah, that's the way we do it. So yeah, I've mentioned local hosts, local host IPs. If you're using dedicated Varnish servers, you'll probably put the IPs of your web servers in there, because the bans and the purges, I'm already using the term ban, that's the next slide. You'll be doing that remotely. It won't always happen on the local host. If your web server is on the same machine as your Varnish server, then local host will do just fine. Word of warning, if you have multiple Varnish servers in your setup, you'll have to do the purge on every single node. So that probably, if you're using PHP, will be a curl multi-call, like empty the cache. Banning is a bit more elaborate. See, there's more code on screen doing that. What I've written here is a ban lurker friendly ban. Let me explain. Allow me to explain. You have to look past all the clutter and focus on what is important. If the method equals purge was still using purge, you can choose whatever you want. You can use Pietje Puk, Peppy and Kokkie, you can use whatever you want to keep it Dutch. But again, we use the access control list to define if it's allowed or not allowed. But focus on that line. And look, I'm gonna help you out for the attention spans. Here, let's do some live slide updating. There we go. This is banning. Banning has a syntax where you can match items that are stored in your objects. If you paid close attention, and I hope you have, objects only contain response information, not request information. Your HTTP request is not stored in the object, only your HTTP response, being the headers and the payload. So what we're doing here is a dirty, dirty, dirty trick to add 2 extra response headers. The URL and the hostname of the request, because that's not stored in there. So we're setting them here. X URL, X host is the actual URL in the host, because otherwise it wouldn't be there. And then we match it here. If we do a ban, we say the X host should be the real host, and the X URL should be the real URL. And it will invalidate that. It will put it on a ban list, and on the next request, it will update the data. That's how bans work. I was under the impression that bans were amazing, and they're pretty good, but there are performance issues involved from what I've heard. Like you can take down an entire Varnish server by issuing too many bans. It's things they'll be working on. I also learned that if you ban something, there is no graceful and asynchronous way of updating the cache without the user noticing. If you have a slow page, and we will be having examples where we deliberately put a sleep in it of 10 seconds to make it slower than it is, everyone is waiting. But then again, for purge, it's the same deal. But the power does not lie in do you use ban or purge for individual URLs. The power lies within the fact, and let's use another color to mark this line. There we go. Boom. The blue line. If I added an extra request header called xpurge regex, regex being a regular expression, I could actually, and this is where it gets interesting, double equal sign, tilde. And tilde means a regular expression match in Varnish. So what we're doing is instead of invalidating single URLs, we're going to invalidate entire patterns. That's useful. If you have lots of stuff to invalidate, and you don't want to be going through every single URL, you say that pattern. If it starts with /products, invalidate it. And you can do it. And this is a way of doing it.
Why? I mean, I've used regex for the VCL already. But
Yeah.
Why is it that only in the VCL you have to not escape slashes? It seems like, I don't know, really weird.
Yes.
You know? Because like everyone is
Like the
regex conventions.
the PCRE, the pro-compatible regular expressions, I don't know. Well,
I mean,
there's a way to know. Ask Paul. But it's more than Paul. Like the entire core, like a lot of people from the core team are here.
Okay.
So maybe you should ask them.
You only have to escape a slash when you have in regex the start and the end with a slash. You can also use custom characters there,
Okay.
like
hashes,
and so
yeah.
on. And then you don't have to escape the slash, but then you have to escape the hash. So
Yes.
And probably Varnish uses a different pattern than slash
Like-
there.
Some hidden UTF-8 character that no one uses. Like the third, the emojis. Yeah. There's other ways of banning. And I've seen like when I look at the plugins, and that's when we discuss WordPress and Drupal and Magento, WordPress uses this in their plugins, this very syntax. Whereas Drupal and Magento don't rely on HTTP calls to invalidate, but actually use that backend connection that we've hinted but never talked about. You can type on your computer Varnish, like if you have a local Varnish installation, Varnish ADM, and all of a sudden you'll be entering that. We have examples on that, like when we hit the examples, we're going to talk about that. And that syntax that I did in that ban function, you could do it right here without having to write VCL for it. Even if you don't have VCL, custom VCL, you can still invalidate through banning. Now you can do that remotely as well if you do the -T parameter and make it remotely accessible and put the security measures in place. You can do a telnet connection, go through the authentication process that Varnish has for you. I have, in the examples, I have a wrapper script that fixes this for you. And then you could remotely connect to Varnish and issue all the kind of bans you want without VCL. Varnish behavior acts like that, and Drupal uses it in their modules. The Magento modules do the same thing. And this is a CLI command. Whoa. This is not supposed to be here. This is a slide that belongs somewhere else. You also have header-based invalidation, and that's what Varnish 4 supports. Anyone heard of if modified since, if non-match, last modified, e-tag, all these very specific headers? Varnish can respect those, can work with those. So if you have, if your browser sends an if modified since header, and I've tried it, I think Google Chrome requires you to set a last modified header and either a cache control header or an expires header. If it sees that, it will on the next request send an if modified since and match that. If Varnish sees that coming in and the object has expired, so let's say you have a cache control of 10 seconds. After 10 seconds, it will do a backend fetch and update the object. That's a good way of invalidating. And it will have either a 200 or a 304 not modified. Now the trick is that you have to account for that 304 in your code. If you could optimize your code for 304s, let's say you have some sort of MVC framework where you can control what requests come in, and you know when data has changed. Maybe you have a distributed cache like Redis or anything else that you have quick access to without having to go through the entire database of retrieving it. You could say, oh, that request hasn't changed, because you keep track of the timestamps maybe in something really fast like Redis or like shared memory. Then you could return a 304 without having to have the impact of going through the entire stack, composing the entire response, and avoid using a 200. You just say 304, it hasn't modified, and Varnish will respect that. You can also use e-tags to do that. Use a sort of hash like ND5 or SHA or whatever you have to identify a request, and use this sort of fingerprint that is called an e-tag. I noticed that Nginx strips off my e-tags.
By default, by Google optimization.
I would advise you, if you wanted, use that one, based on modification. If you really want it, you'll find ways around it. You can use, instead of using if modify since, use the if non-match, and you'll have the same 200 and 304. There's a variable in VCL that you can use to define the time frame where it serves all data. And this is useful. There's bref.keep. You can set a value to that, and during that interval, it will serve the old data while a conditional request is being made to the backend. So you could not bother your user with that. Backend connections will be made, so that will cause overhead, it will, but only when the object expires. So that should not be so bad.
So basically what it does is it gets your request, it sees, okay, it expired.
Yes?
And instead of sending to the backend and then sending the response from the backend to the client,
Yeah.
it sends the old response, and at the same time sending the backend
A
and
request.
then cache that.
Yes, and if the backend is optimized for 304s or for those kind of things, you can make that really low impact. But again, as a web developer, you need to account for that.
So this for the
next user.
Yeah, for the next user. Because that header will be sent by the browser. Similar to keep is Grace. Grace also serves all data as already it's used. Like if you assign a time value, like just like the TTL, like 3 seconds, an hour, a week, or whatever, it will keep serving stale data if data has expired and there is no conditional request. That Grace mode will keep serving the old data while it's fetching the new, but only for expiration, not for invalidation. So if you're doing a ban, that won't happen. If you're doing a ban or purge, it won't do that. But if the TTL has expired, you can use Grace mode to just still serve old data while the other data is being fetched from the backend. To make sure that your user doesn't feel that delay. It's again a trade-off between serving fresh data and not making the user wait. But it's also cool if your backend is unhealthy, you can write an if statement like if backend not healthy. You can ramp up the Grace mode and it will keep serving the old data even if the backend is down. And you define how long. So if the backend is not behaving well, you could say, we'll set the Grace mode to half an hour. And that gives us half an hour to solve that backend problem while Varnish is still serving old data. After that, it will give you a 503, an ugly old 503 error. Last chapter, I guess, before we dive into the examples. Monitor and logging. I find that to be quite important in Varnish. And I work at a hosting company. We deal with other people's crappy code and other people's crappy VCL, unless you've paid us to optimize it. So we need to see how it behaves. You want to have a clue about what your hit rate is. It's all about the hit rate, right? And there's a set of utility tools in Varnish to help you out, figure out how Varnish is behaving. First one is Varnish Stat. It's a real-time statistics binary. If you run it, you'll probably get output like this. It says that the hit rate is not that brilliant. The hit rate is the last 10 seconds it measured it. 0.8, so 8% hit rate. The last 88 seconds, it was 14%. It's low, it's not that good. Then again, I'm not sure if you could use that as an actual proof of the hit rate. It's an estimation. But what you can see is the current value and then the changes that happen over a second, and then the values, average over the last 10 seconds, average over the last 100 seconds, 1,000 seconds. You can see that in total, since it was started, there was X amount of sessions being made. You can see how much hits, how much misses. You can see the ratios. And you can have a pretty good idea of how things are behaving. How many objects are in cache, how many objects have expired, how many, and so on and so on. It only keeps track of a collection, a set collection, but you can expand that collection. If you run Varnish Stat -- help, this is your syntax. By default, I've been using that phrase by default a lot, but still it is true. By default, it will continuously update. So you type Varnish Stat, you press enter, and it will give you real-time updates. If you do -1, it will only do it once and print it the standard out. And then you could do things with it. You could filter by adding -f fields on values you want to have in there. Maybe you don't care about everything. You want specific counters to be there. You can use multiple -f fields, and if you use a caret, it's a negation. You say, we don't want this one, we don't want another one. -l is a trick. When you do Varnish Stat -l, you see all the available counters with an explanation of what they do, and then you can have a pretty good idea of what you have, and then you can decide what to use. You can define the intervals, but here is when it gets cool. By doing -x or -j, you can format that to JSON or XML and do things with it. So if you, and it will also print it once. It won't, as soon as you do -x or -j, it's the same as adding -1 to it. It won't continuously update. It will render JSON or XML, and then you can parse that and use that in your own application. So what we're doing here is Varnish Stat -f cache hits -1, and it will only output it once, and it will say the amount of cache hits we have. If you do add -j, it will give you more information in a JSON format. And it continues on. We want a number of objects that are in cache and a number of objects that were nuked. So nuked means if the cache is full, it will start selecting items that have to be evicted. And it does that based on which strategy? LRU, least recently used. Exactly. So things that aren't, so it will keep a track of a list of the most popular objects in cache, and the one at the bottom will be evicted in favor of another object. If that number is high, it means you're running out of memory. But maybe that's not so bad. It's not like it's the end of the world that you run out of memory. It's not that Varnish will certainly crash. It will just evict, and that way, if you have so much items in cache, like we have a client, that's interesting, a Windows client, so they build all their stuff in .NET, they use SQL Server. I like SQL Server, it's a good database. And they have Varnish in front of it. They're a campaign-based website. They're called Vant Exclusive, and they're doing like invite-only discount sales of specific items. So they have huge amount of assets, but they don't care about everything, storing everything in cache. They only care about that sale that is going on that week. So if Varnish starts nuking things, they don't care, because it's old campaigns. It will end up in the bin. And because those old campaigns don't have any hits, the hit counters don't go up, and it will be LRU. Not that bad, but to go back on topic, you could choose number of objects and number of evicted ones. You can also do like Varnish Stat -f main.cache asterisk, and it will match everything that starts with main.cache, and you can see your hits, your misses, and what they call hit for pass. And hit for pass is that set bresp uncacheable thing. It used to be called in Varnish 3 hit for pass. That's our blacklist where we store past data, and past data is data that is considered uncacheable. And then you can see how many items over the course of our running instance. That's as long as it's been up. And then you can see the ratios per every X amount of seconds. You have a bunch of counters that you could look at. You have session information, client information, uptime information, hit, miss, backend, memory, objects. You can filter on all that stuff. That's more of a sysadmin thing. As a developer, you do less of that. But maybe if you have a running instance, you might want to know how it's behaving in terms of hits and misses. This is where it gets really cool. Varnish log is by far my favorite monitoring tool in Varnish. The reason why I advise everyone to upgrade to Varnish 4 is they completely overhauled the way Varnish log works. The guy responsible for that, sitting in the next room, Martin, he rewrote it. Now Varnish log, I will have to warn you, is very verbose. Don't run that on a production server, because it will just keep throwing stuff at you like crazy. But it's an in-memory log of Varnish activity. Mind you, it's in memory. It's not storing it on disk. You can't fill up your disk. But I think if you run Debian, the logs will also be serialized to disk and will be log rotation to make sure that it doesn't entirely fill up your disk. Woof! Lots of output. Luckily, there's syntax coloring, or coloring. I grouped certain things that are useful. This is the ideal way to see how Varnish is behaving. Like truly the ideal way. Question, is it readable in the back? Can you still read the small print? Because it had to fit on screen. Your request comes in. It's request number 1. Here's a timestamp of when it started. The thing in blue are all our request information. The start of the request comes in on this local port, on that IP. The method is a get. The URL is /exercises/1/max.php. We are speaking HTTP 1.1. I'm glad to do so for the time being. It will be 2.0 anytime soon. All our headers, the hosts, the connection information, the accept information, it's all there. So you can see what the client is sending you. Then our first decision to be made. We're receiving it. It's good. And then we're hashing it. That means there's no cookies. Not seeing any cookies. It's a get or a head. There's no authorization headers. That's our default behavior. Okay, that happened, so we're hashing it. We're looking it up. We're calling the hash part. We're looking it up in cache. It was not there. It was a miss. So what we're doing is we're fetching it from the backend. You can clearly see that. Then the link is being made to request number 3, which is a backend fetch. I'll show you request. It's a different block where you do backend connection. When it comes back from your backend, this is what you're getting. A 200 OK served from Nginx, 10-second cache control using max age. It's fresh, 0, which makes sense because we just fetched it. And then we're going to deliver it. And that's it. It's very verbose. It shows you exactly what is happening. Let's do the backend information. Backend tree. This is the information about the backend connection. You begin with a backend request, and here is all your backend request information, which is an exact copy of that. You send it through, it does a backend fetch, it fetches it, all good up until this point. This is the backend response information. TTL, also a useful one. We're using RFC-based information. What is RFC-based information? Cache control headers, expires headers, those sorts of things. It will be cached for 10 seconds. And apparently, I think, not sure if that means 10-second grace mode. There is documentation about this, and I'm going to write a blog post about that soonish. I'm also writing a book about Varnish, so that will probably be in there. I don't know by heart. These are timestamps, and these are values that were set by the expires header. There's no expires header, but there is a 10-second cache control header. So you can see it there. It means it's getting cached. We did the backend response, and we're delivering it. That's the second stage. And this is the object that will be stored in cache. Next up, we're doing the same thing over again, directly after that. Different timestamp. You get your requests. What happens? Receive, hash, lookup, hit. No backend connection happening, delivering the response from the object. Hit, miss, you can see what's happening. You can anticipate. If there's a running instance, you can easily track down what is happening and then maybe improve. Oh, a header is being sent that wasn't supposed to be sent. That way you can control it. But doing this on a running instance will cause you headaches, literally. So you want to start filtering information that is useful to you. If you just run varnish log, everything will appear on screen. If you run varnish log -i will be as a tag filter. I'm going to show you tags. This column, these are tags. You can filter by it. You can say, I'm only interested in the request URL. Or I'm only interested in the request URL, but group all the information raw. So that means as they come in, it's like just floods you with requests. There's no grouping. But you can also group by request. So it will, because if you have a running instance, luckily we're grouping it by request or by session. But if you do it raw, you can have requests cycling through because it's multi-threading, right? And it would be highly unreadable. But if you just care about the URLs and nothing else, you just do a raw grouping, do the URLs, and you just see URLs coming across your screen. Request URLs. You can also say, I'm interested in request headers as well. Or I'm only interested in client connections. Client connections being that piece of the puzzle. That slide. Only interested in clients. Or you could say, I'm only, by doing -b, only interested in backend connections. Or you could say, I'm only interested in request URLs that resulted from a hit. So I want the URLs to be hitting. And then you do a -q. And this is new in Varnish 4. That's the Varnish query language. And it has a little query language in it where you can say, I want to filter, I only want to tag rec URL, but before I do that, I want to filter and only get information where the VCL call equals hit, so where there was a hit. And you get the URLs that hit. Or you could say, here's the next piece of the puzzle. I'm interested in to see URLs where there was a miss or a pass. Miss being it was cacheable, we didn't find it, or it was not cacheable. And we also want to have other tags. We want to have the VCL call tag, but only if the VCL call tag equals a pass or a miss, not the other stuff. And then you can see pass or miss with the URL. And you have a list. Was it passed? Was it missed? You can easily spot that. Or we want to have all the URLs where the processing time took more than 0.8 seconds to identify slow requests. Very useful tool. Even if you're not using it to cache, you can track down slow requests or slow processing. Next up, Varnish top. Varnish top is the same thing as Varnish log, but incremental. If you run Varnish top, it will just increment the most popular tags. But you could say, I want to know what the most popular URLs are. You do Varnish top -I, rec URL, and you see the most popular URLs. You can have the most popular VCL calls. You can have the most popular URLs that resulted from a hit, most popular hits. You can have the most popular misses. You can have the pages, the top pages that are slow, and so on and so forth. So that gives you a sort of, it's like top on Linux, but for Varnish requests. And as I mentioned, this is just for me to be okay with the description they gave, the way it marketed. Yes, Varnish runs with Drupal, WordPress, and Magento. It's just a matter of finding the right VCL and the right band module. And we can, if you're interested, we can talk about that afterwards. I have a bit of information for that. But I think the time has come to do exercises. We have a half an hour. Guess it's until 12, right? Right? Well, it's up to you as well. And we're going to do some exercises, and I want to know if your laptop setup is working. Now, you can be lazy. I don't care. Like, you can watch me do it. You can do it yourself. I don't care. If you want to do it, I gave you the instruments. I will now go from, I go to a mirrored screen now, and I'll show you my console, and we're trying to figure it out. I have to warn you.
I have one question.
Yes.
Is it possible in Varnish Stat to filter on a subfolder? So to see the hit rate from everything in /shop?
Yeah, you can use regular expressions for that.
Okay.
We could do that as an example later on. Like yeah, sure. Okay, I didn't over prepare this one, so it'll be like very loosey-goosey what we're doing now. Let's see how this works. Wow. This is very small print, and I might be blocking. Yeah, I'll increase the font size. Don't worry. I might even be blocking this with my face. Is that true? Am I?
But that's fine. So
Okay.
only the bottom.
left.
Yeah.
Appearance,
You're up there.
colors and fonts. Font size 20. 20 would be good, I guess, right? Is 20 good? Is that readable?
Yeah.
So let me explain how that, let's exit full screen mode. And we're going to do the same thing here. Readable?
Yes.
What? No? It's not good?
Yeah, no.
Changes to be made?
I just saw that you were using it. That's pretty fun.
Thanks. This is my Git clone. What it contains is a Vagrant file. And that Vagrant file downloads a box that was publicly uploaded on the repository. That makes sure that you don't have to do any crazy installs. Everything is in there. So if you have it, it should be working. I named it Varnish Training, and I have some custom IP space, 10.10.10.6. I would advise you to put that in your host name with varnishtraining.dev as the host name. And we gave it 0.5 GB. It should be enough for the examples, because it's not that big. When you do Vagrant up, I think it's already upped. It's running. Vagrant SSH, sudo su, and you are in. That's all you need to do. Let's have a look. Oh, the audio is also transmitted, so. I'm not sure if you can. No, I cannot. This will be annoying for you guys, because every time I hit something, it will constantly. What we have is a Varnish etc system, like every time I do tab completion, it will suck. Is there a way to do syntax on this? No. I linked it to port 80. I have a 6082 admin interface. I have a default VCL. We've disabled XML checks. It's pretty standard. Quarter of a gigabyte of RAM. Don't need more.
In your settings, under advanced, you can change the bell to a visual bell.
Whoa, you're awesome. Let me.
And in advanced, last tab, and then you have your
Bell.
bell, warnings, bell, thingy.
Visual bell.
Suppress. Yes. Visual bells. Yes. Is that the thing?
Yeah, it's an auditive bell to
Yeah.
switch on, off, and a visual bell to turn on.
Great. Thank you. Very grateful for that. We'll use that in future presentations. So this is a plain and simple one. Motherfucker. Is there a way to mute the audio on that? Yes. Yes. Great. What was I about to say? Oh, I wrote, so if you go to /vagrant and you do ls-l, you see two PHP scripts, one that is working, one that is, I'm a bit doubtful if it's working. The clear cookies Chrome is one that you have to execute on your local system, and what it does is it reads the SQLite database that Chrome has on your Mac or Linux, it's primarily for Mac, and it will delete that cookie from the SQLite database. But I've noticed that it does delete it from the SQLite database, but it's still in memory, I guess, in Chrome. So, word of warning, make sure you know how to empty specific cookies for varnishtraining.dev in your browser, because sometimes we will need that. Another file is the choose exercise file. If you run it, choose exercise, it will ask you which exercise you're interested in. For the time being, let me put that here. It's exercise 1. You press 1, and it will reload your Varnish. If we look at etc Varnish default VCL, it's the simplest of simple. There's nothing spectacular happening there. You can also decide yourself, like if you want to do it quickly, I've built in argument support, so you can use, you said example 2, and boom, example 2 is loaded. Sometimes there are sub-examples, so choose exercise, maybe 7, and then it asks you the sub-exercise 1 to 7. But we'll use that when we get there. Let's start with our very first example. I can't increase the size of this. Let's go for max. So I've written a small PHP script, and I think we'll be able to go through this pretty quickly because it's so simple, but I just wanted to show it. It's also something you could take back home and experiment with. What I'm doing here is just caching it for 10 seconds based on the max H cache control header. Here's where it gets cooler. Exercises 1 max.php. It will just cache it for 10 seconds. So that should be all the way up until 36:17 the next time. Or 18. 17, see? Basic, very basic. A lot of these examples will be basic to start with. It's just a point I want to prove. Another example we could do is use the smaxh header. That's smax. Look at it. I'm combining a maxh and an smaxh, and then the question arises, how long will this be cached? You know the answer to this? How long will this page be cached?
5.
5, exactly. If we do this here, it's 48. 48 plus 5 is 53. Boom, 53. I'm bad at math. What else do we have? We have mixed headers. A mixture between the expires header, the smaxh, and the maxh. Expires is cached for 15 seconds, maxh 10 seconds, smaxh 5 seconds. Question again, how long will it be cached?
5.
5 indeed. You know your priorities. VCL, SMax, max, expires. And I could show that to you, but I don't think it really makes sense. Let's find more interesting ways of doing it. You can use no caching headers whatsoever. None. Question is, how long will that be cached? 120. Let's try it. Hey, let's use some Varnish log magic to actually see it. Varnish log minus G raw minus I TTL. Let's go to none.php. RFC 120. See, it caches it for 120 seconds, and we have Varnish log to prove it, that it works. And we have more examples, of course. TTL 0 reverts to default behavior, will not be cached. Was that TTL 0.php? Whenever you refresh, counter the date continues updates. You see RFC 0, VCL 120. So that means you've set it to cache for 0 seconds because the max age was 0. We won't cache it, but we'll blacklist it for 120 seconds. That is exactly what's happening. Now I want to show you, not for the sake of the example, but rather for the output in Varnish log. When we do an expires, it will not have a cache control header, but that is the timestamp of expiration. Unix timestamp of expiration. So that means it will be cached for 10 seconds, I guess. Is it? 10 seconds, yeah. So your TTL is defined here, but you can see that it's based on an expires header. Whereas if we use, again, our max.php, you see that the expires header is 0, but the cache control header is 10, which results in 10. Easy to spot. It's a good tool. I'm constantly going to try to prove it to you, and Varnish log is a good tool to use to debug. Is there anything else in that example? Oh yeah, the syntax. Ever since Varnish 4, it does respect private, no store, and no cache. So if you mention either no store, private, or no cache, it will not cache it. It will set it to uncacheable for 120 seconds. The last thing I want to show, or there's two more things I want to show you. Let's fiddle around with the age header. The cache control header, SMax age is set to 30 seconds, so you'd be expecting that it would be caching for 30 seconds. That is not true, because we're setting a custom age header. How long will it be cached?
5 seconds.
5 seconds, exactly. Let's keep our logic here. Open this one, age.php. It will be cached for 30 seconds, but because we fiddled with the age, let's see, 5, see, and then the next one should be 10. There we go. That was example 1. Example 2, let me show you the VCL for example 2. What will happen?
3-second TTL.
Yes, 3-second TTL. So the way we do this is clear this. PHP, choose exercise 2. Boom, the VCL is loaded. I'm going to prove it to you. 3-second TTL. And I have a separate example. Index, it will cache it for, it will try to cache it, not will cache it, will try to cache it for how many seconds? This is repetition. This is repetition.
3. Well, we'll try to set for 5.
Yes, that's exactly the case, but it will end up being 3. So let's go to example 2 to prove our point. Whoa.
It's 1 second.
Something is wrong. So, Varnish log to the rescue. What is happening here? Oh yeah, I know.
You're hitting Apache.
Yeah, I'm hitting Nginx.
Not Apache.
It's Nginx, I guess. Sure, it's Apache? Okay. Let's see if that's true. Oh, no. Curl -I. It's Nginx. But there's an Apache on the machine as well.
Because you're on
but-
8080.
What?
You're on port 8080.
Yes,
And
that was the
no
goal to
80.
prove that. No, I know. That
Okay.
was
Sorry, I was...
the point to prove that it's an Nginx. Reason why? He's done some examination on my box and noticed that there was an Apache installed, I guess.
And
But
with
I'm-
an assumption which is not correct.
Yeah, but you're right. I started with Apache and like, I want to have multiple vhosts that listen on different ports. Nginx is more flexible to do that. So I picked Nginx. So yes, that concludes exercise 2. Let's ramp it up. Let's try default behavior in Varnish. We're going to example 3, which has the exact same VCL as example 1. Example 3. What we're trying to do here is prove how Varnish decides what to cache and what not to cache on a default behavior level. This will require you to empty your cookie bin every now and then. Otherwise, the next examples will not work because it will keep track of the state. What we're doing here is trying to set an authentication header just to prove you that Varnish takes that into account. Exercise 3, auth.php. Boom. Set a username, set a password, and you can see what we saved here. And it will not cache it. We need some proof of this. So do varnish log -g requests -I rec URL -I rec header. We're interested in the headers. -I VCL call -I VCL return. Do that again. Oops. Right? Oops. Am I on 8080 again? Damn,
Still.
yes. Still. Oh yeah, of course. It will pass. It will ask for this. Let's clear it. You're seeing the authorization header right here. Basic auth being sent every single time because it's stored in my browser. Receive, pass. Hash lookup pass, so it's actually saving it in the fact that it doesn't want to cache it, it's saving it in cache. This is uncacheable. This is proof that it is uncacheable.
Is it going to be uncacheable for 120 seconds?
Yes, and after 120 seconds, it will make that decision again.
Okay.
Here's the crappy part. I need to get rid of that authentication header in my Chrome because all the next examples will fail because it will continuously send it. So I'm not sure how to do that.
You can disable caching in the developer toolbar.
We,
Just open the developer toolbar, go to network, and then disable cache. So cache everything.
but it's just, I just want the auth headers not to be sent.
Put a cookie.
It's not a cookie. It's just that header. I need to get rid of that header. So, cookie.
Restart your browser.
Browsergegevens wissen. Remove browser settings. Let's empty everything. Varnish. Training. Remove it. Done. Next one. Cookie. Let's do it. Let's set a cookie. Cookie is set. We're not caching anymore. Is it still there? pass. You see the pass? It's not doing anything. Removing that cookie. What else do we have? A post. Post will not be cached. Same deal. This gets cached, because that's a get. Although I wonder, it's that damn authorization header again. Maybe restart my browser would be a really classy idea. All right. That's a hit. Surely is a hit. Send data, boom, post it. Every time we post, we get an updated timestamp. Post does not get cached. Let's try this one. This is going to be a fun one. And let's add some max H logic to it. "10 seconds, right? It's going to be cached for 10 seconds. Everything is smooth. Now I'm going to set another header, 202, accepted. Doesn't get cached. There's only a limited set of methods that Varnish will cache. 202 is not one of them. So if you have a 202 and you want it to be cached, you need to account for it in VCL. TTL0, we already had that one. If you have a TTL0, your backend response will pick that up and will render it uncacheable. That's because we decide what is cacheable in theory, and then from the backend we decide if we want to cache that. And TTL0 is very much such a thing. Very, very asterisk is similar. Doesn't get cached. That concludes exercise 3. What does 4 have in store for us? The Varnish log tool. Yeah, we could do some magic with Varnish log. Let's load script for 4. It's just the default one. What do we want to know? We want to know all the misses, perhaps, right? We want to know misses. Varnish log, we just want to know about the URL. We're going to add a query parameter. We're going to say we're interested where the VCL underscore call equals miss or VCL call equals pass. Seeing the misses coming in? There's still some request grouping happening. Maybe we want to remove that. -G raw. As they come, raw. Raw, not raw I, raw. Always the same story. Screw that. That's more like it. We're doing bad things here. This
Rec URL is supposed to be all caps. I mean, the URL, the URL. Does it need to be all caps?
No, I don't think it does. VCL call equals pass or miss. Something is off. Maybe that doesn't work when you do raw. Could be very much the case. What the hell am I doing wrong here?
Oh.
Do you see it? Let's go back to one of the... What the hell? Yes, and it suddenly decided to work. It probably was a typo in anything I did. See, it comes in. We see the misses. We could do the same thing with hits if we wanted to, and you'll see the hits. Anything particular you would like to explore? You would like to know? No? Have I proven that Varnish log is a good tool? Oh, a thing I could do, I'm going to copy paste it from my slides. Is I've created a Varnish log example. Here it is. Let's do this one. Oh, yes, please. It's not behaving that well. What we're doing here is using the -I parameter to filter the output. So we're filtering the list we're getting by saying we only want misses or passes. We're interested in the rec URL tag. We're also interested in the VCL call tag, but only if the output equals pass or miss. That way we don't flood it with things we don't need. And if we execute this and we run our miss, you'll see the accompanying, it was a pass. It wasn't a miss in the first place, but let's do a dirty trick here, vagrant SSH. Invalidated it. That's the invalidation part. And it should become a miss, if I'm not mistaken. See? Yeah, it's a miss. And I ran varnish top, not varnish log. That's why the output is so quirky. See? Pass. If we do that invalidation step again, go back, it should be miss. Still pass. Whatever. I proved my point, right? We're running somewhat out of time, so we need to ramp it up. Otherwise, we'll be stuck here for a while. We could do the same thing with varnish top. Let's go back to, we want to have the most popular of URLs, varnish top. And we could go all the way through, bam, 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 bam. Miss is very popular. We also have hit.php. It's in there. It outranks, miss outranks. You can do the same querying syntax as you do, and you will have the most popular ones. Let's pick up the pace. Example 6. Oh, cache variations. This is a lot of fun. Caching for 20 seconds, varying on the accept language head. I have a Chrome open and ready for action. At exercise 6. Boom, 6 is now loaded. Cache variation, still on port 8080. Firefox has a different variation. So timestamp 5638, 5632. See? It was a cache variation. Why? Because we varied on the accept language. That is an effective cache variation in action. Agree?
So you now got
two objects.
two objects in the cache.
But they're identified by the same hash. That is also useful to know. So if I would ban, and let's do that. So 5710, we ban by URL exercise 6. What the hell am I doing? Exercises 6. Yeah. Yes. Both of them will be invalidated. Same hash key, different objects, but composed and kept track of. Load balancing, yay. Let's do some fun stuff. I have an index file where it says, not the date this time, we don't care about the cache, but on what port we're listening. You have 2 instances of Nginx, one running on 8080, one running on 8081. So let's do it. Example 7 has sub-examples. 7.1 is a round robin. I'm going to prove that to you. .1. .80. Oh, no. Same problem as always. 8080, 8081. One, round, robin, round, robin. 7.2. What is 7.2 all about? Randomness with an equal weight. See, there's a lot of 80-80, all of this, that's randomness. We can give Nginx a bit on the second instance, Nginx 2, that listens on 80-81, a bit more. So that's 7.3. Let me clear that screen for you so that it's higher up. 80, 81, lots of, it's still randomness, so you can't really control it. 7.4, hashing, based on the client IP. We'll skip that one because we only have a single IP on this box, but you could do it if you find ways to. This is a fun one. I'm doing distribution, hash distribution, with equal weight, but based on the value of the A parameter. So if I have question mark A equals a value, it will either hit the one or the other. 7.5. It is 7.5, right? Yep. A is A, always hits 80. A is B, always hits 80-80. Go back to A. See? Based on that URL parameter, not the full URL, that parameter. 7.6 we'll skip because that's the same deal but with the full URL. 7.7, the last one, is fallback. What we did is we have a probe, exercises 7, down.php. If I enable this, it will generate a server error and it will cause it to be down. So let's do it. 7.7. See if -g raw. Yeah, it's pinging the backend health. With an interval I decided. If we look at the VCL of 7.7, you'll notice that the interval is a single second. So every second it will say Nginx is still healthy. When we go to exercise 7, it's always 80-80 because the backend is healthy. You can see the other stuff passing through. Now we'll play a dirty trick and disable or make sure that this is no longer healthy. Do a 500. Went sick. Still sick. You can see it. Varnish log is a good tool. Boom! 80-80, fallback. It's done. Now that health check thing is not only for fallback. You can also use it in round robin, in randomness, and it will just only select the healthy node. So let's say you have 5 nodes and one becomes sick and you have a probe to measure it. It will throw that one out and you will be fine. That was load balancing. Exercise 8, invalidation. We'll just have 8.1 We'll do regular purging. See, we only do purge. If we execute a purge, it will purge it. It will be out of cache. Varnish Stat minus F. Varnish Stat. Varnish Stat minus L grep. Number I need to find and number of objects. Varnish Stat minus F number of objects. It has no objects in cache. That was 8 if I'm not mistaken. Boom. It will cache it. If I'm not on port 8080, it will cache it. See? 1 object in cache. How long does it get cached? That's my question. Hope long enough. An hour. So it will be there for an hour. Now we're going to invalidate it purposely. Split, vertical. See that we have a single object in cache. Curl minus X purge. 0 items in cache. 200 purged. Update it. Point proven, I guess. You can see that it's back in cache. No longer in cache. You see that counter decreasing? That's what it's all about. That's a regular purge. We can do more. 8.2. We'll use a ban. Let's do a ban. One item in cache. Invalidation happening. 1 item in cache, still. It didn't remove it from memory. It added it to a ban list. I can show you vagrant, varnish ADM ban.list. It's on there. It's on the list of things to be banned. 1 item in cache. When I, boom, timestamp updated. Still 1 item in cache. It didn't remove it. It marked it as invalid. You got the value, updated it. That's what a ban does. 8.3. What are we doing here? Ban lurker friendly bans. We'll skip that one. That's the way you should write your bans normally if you do it. 8.4. Aha. ACL. Now you have to check this one. .405, not allowed. .200, ban added, done locally. My machine, my VM, my computer. And 8.5, and this is the fun part, pattern matching. We're going to invalidate patterns. Boom, done. We're going to put stuff in cache. This page, 1, 2, and 3. There's apparently 4 objects in cache. Now we're going to invalidate the entire pattern. So let's see if there's an ACL in there. No, I removed the ACL. What we're going to do here is set a header, exercises 8. Minus H, set a header, X, purge, regex, colon. Hope that works. Exercises 8. Everything that start with exercises and 8 will be invalidated from the cache. Ban added. Let's check. Update it. Update it. Seems like it's working. So we just, and that's important to know, we just tailored that one around the URL. But you can use other things, like we want to invalidate the cache for everyone that uses Google Chrome, or for all objects that have been stored there with an age of 100 seconds. You're free to do so, but URL invalidation is the most common one.
How would you ban or purge when you have multiple instances? Because
multiple instances of Varnish?
yeah.
Just connect through multiple, make multiple TCP connections, or multiple curl requests.
But then you have to do it by Varnish up and down, right?
No, but like, let's say you have a curl for every single instance. On the place where you invalidate, maybe that's on your web server, you will do multiple curl requests. Instance 1, instance 2, instance 3.
Yeah, but you need the URL, right? And that points to the load balancer and then goes to one of the servers.
Yeah, what you could do is this trick. You just go to the IP addresses, but do specify the host header, and we'll do it the similar way. And then you could have the individual IPs of all your Varnish instances and do it that way. Then again, if you're familiar with Varnish ADM and the TCP IP thing and the way it works, use that.
That's better.
It doesn't require VCL. It doesn't require HTTP. Depends on what you like. And then you don't have to write, you don't get locked into the VCL that you have for purges. Because you don't need to prepare anything. You could just say, right in here, Varnish ADM ban obj.htp.h is bigger than 10. Oh, no, it only works like 10. If it's 10 or 100 or whatever. Like we're being creative on the spot, not having to write VCL for that use case.
Then you have to open the port for public network layer.
Yes, and add firewalling, those sort of things. So it's a trade-off. What's more easy for you? Like, do you like the flexibility? Are you worried about the fact that you have to open this? What about the secret keys? Do you have a revalidation policy on the secret keys? How do you do the authentication process? And so on and so forth. This is a script that I wrote to do the invalidation yourself. The authentication yourself. Maybe I should prove that point. Like if I do Varnish ADM, we'll do it automatically. But let's say let's clear the screen for your comfort. Telnet, localhost 6082. I'm not sure if I'll be able to do it. It's a bit complicated. It will give me a challenge. And then PHP, no, exercise. We're already exercise 9? No.
10.
10 already? Whoa. That went fast. We've skipped a couple. It's not that I'll show you 9. PHP, secret.php. Why is it taking so long? Oh, it reads it. Oh yeah, that was a challenge. Enter the secret key as... Oh, you have to pipe the secret key. I'm wasting your time here. Vagrant, SSH. 10 seeker.php. And this would then be my challenge. And I think it's 200. No, it's a different code. And you have to know what the status codes are. It's complicated. But a lot of modules, there are modules out there that do this for you. We forgot about exercise 9. That is indeed the case. What I do in 9 is nothing specific. 9.2. Oh, I show you how query sorting, that it impacts you. We know this, right? Because we're running out of time. It's already 12:15. Do I need to show this, or do we skip to more interesting things? Want to see it? No? Next. I will do exercise 11 as the last one, but that will require lots of cookie removal. So exercise 12, grace mode. So I'm going to cache this for 10 seconds, but I am going to enable grace mode. And grace mode will be set to 30 seconds. Let's prove it. That's what I really hate about it.
Control-Shift-6.
Control-Shift-6, thank you. "30 seconds grace." Exercise 12. And show 12. So we set it to 10.
It's
Should-
still on 8. Keeps redirecting you back.
What the hell? Should be 10 seconds, but in reality it will be longer.
40. No, okay.
30 seconds is an awful long time to wait. Okay, point proven, right? Grace mode extends that. Like, let me do another trick to prove the point of that. Let me etc init varnish restart. It won't be in there. Boom, it's there. etc init d nginx stop. Web server is dead. But it has expired. Still works. I have 20 more seconds to fix my backend. Next one. 13. Edge side includes. It's like I build up to edge side includes because that's the coolest thing in there.
One question about
Yes.
the grace. If the grace is set to 30 seconds,
Yes?
it's automatically adjusted to 40 then?
Not always, not always.
It's available. I would suspect if the backend is there, the grace period is 10.
It's only for invalidated content. Like you just say with grace mode, serve stale data longer.
Yeah.
That's what it does.
Yeah.
Let's do the edge side include thing. I see the other session has ended. He's a good guy, Ruben. The two-step process, announcing that we understand ESI. If we get a surrogate control header back, all will be fine. Exercise 13. Now I will deliberately connect on port 8080. Exercises 13. When I do that, oh, moved permanently. To where? Right here. Did I make an error?
Slash behind the.
Ah. See, it generates these ESI tags that it cannot understand. Turns it into valid HTML. Let me show you that in the browser. Refresh our page. Our top counter is the counter for this page. The other counters are for the included tags. So you could fiddle about and choose what should be cached, what should not be cached. This is how I've done it. If you're, I wrote an extra example. It does the same thing, so I won't show how it runs because it generates the same output, but it uses the Symfony thingy. I'll show you what it does in Symfony. It uses Symfony HTTP kernel, which is, if you're a PHP user, that's the way to go for HTTP processing. And what I do is I create a request. You have the ESI object, and what we're doing here is saying, if we have surrogate capability, only if, we will render the include tag based on the base spot, and then that snippet I'm including, and I'm adding the TTL as a URL parameter, just for the sake of it. That's not really a best practice. Then I will set the content to be the actual content, add the surrogate control header to the response, set a shared max age on my main page of 10 seconds, and send the data. Same output, nothing special. I like that idea, but a lot can fail on you. I forgot to show you something of example 1, the conditional backend requests with the last modified and the if modified since. I think I owe you that one. We're almost done here. If modified since. Setting last modified date on my file and a max age of 10. If it expires, it will look, and if the file time is still the same, it will send a 304 not modified. So let's do it. We need to set up the varnish log to prove it. It's really slow. I did that deliberately. Make it slow. Sleep for 5 seconds. And after 5 seconds, it will come in. Well, let's hope I could prove this point. .304, not modified. Okay? It can handle 304s. I don't have to go to the page though. It goes pretty quickly to 304 because that happens before the sleep. That's why I put the sleep below the 304 so that I can prove that if you optimize your flow that it can handle 304s, you don't have to go to your full stack, your full code stack. You only have to go to that little validation piece. And if I would then change the content of this file, like file and time of this current file, it will generate a different last modified header, and then it would update the cache element and so on and so forth. I think the very last piece of the puzzle is proving how to work with cookies. Oof. What do we have? Which example is that? 11. Default behavior. Oh, the hit miss. That's a fun one. 11.2. Miss. See it? Hit. 5 seconds old. 8 seconds old. 10 seconds old. 11. It's a hit again. Set it to 1. So it's an easy way as a developer to see if it came from cache or not without having to log into your Varnish service, because maybe you'll end up in situations where you don't have access to these machines. And then a simple hit-miss marker and your age and the fact that you know what the cache control headers are is a good combination to know how long it will be a hit if it's a miss. So on and so forth. Then 11.3. What we'll do here is use a language cookie and have a cache variation based on the language cookie. I hope that example works. 11.3. Language cookie. Now we need to find langcookie.php. All right, 11. We select English, and we're caching this. We're selecting Dutch, and we're caching it. 2358, 2347. Cache variation based on a cookie, language cookie. Convenient. Hey look, it's Paul, the inventor of Varnish. He's standing there wearing his FreeBSD sweater. In pride. Sanitization, yeah. I think I've proven my point all the way up to now, and I think we can end this. I have a slide for that. This one, the end. I really, honestly, and I'm gonna stand up out of respect, thank you for being here for the last 3 and something hours. It's been a while since I've last done this training. It's not been a while since I've done my last Varnish presentation. And I hope that was a healthy mix between theory and practice, and that these examples, you can take them home, you can play around with them. You can learn more about Varnish, A, about default behavior, and B, about using and harnessing the power of VCL to tune your Varnish instance towards your applications. Honestly, I'd like it the other way around. If you can tune your application, and as you can see, lots of headers could do that, tune your application towards HTTP in general, you'd be better off. So thank you for hanging out with me. I'm not sure what you're doing this afternoon. I'm going to the VMod session by Ariana, learning how to write Varnish modules in C, brush up on my C skills. I think it's lunchtime. Thank you.